So today we are up with a mission. We have to send a spacecraft to Jupiter. So we'll use the fastest rocket for it, the Atlas 551, which was used by New Horizons to reach Pluto. The only catch here is that our spacecraft is 7 times heavier than the New Horizon, so it would require more boost than the New Horizon. So let's launch and see what happens. So we had a successful launch for our spacecraft, but we have just reached the asteroid belt. That's just halfway to Jupiter. There's only one thing we can do now. Take the help of other planets' gravitational field to get a slingshot to Jupiter. So the technical term for the slingshot is a gravity assist. This has been done by Voyagers and many more missions. Okay, as I told you before, we have just reached the asteroid belt. So now, because of the sun's gravity, we'll be pulled back to the position where we started from in our orbit. So now, as we reach the position, we also want the Earth to be there at the same time so that we can take a gravity assist from Earth. So these missions, like the Voyager and other missions, are planned so perfectly that when the spacecraft reaches the position, even the planet is there to give us a gravity assist. So we'll do the same in our case. So how does the gravity assist actually work? The planet's own motion is the key. The planet has an enormous angular momentum as it revolves around the sun. As a spacecraft is a physical mass, so it has its own gravity. That's how a spacecraft can tug on Earth and actually decrease the planet's orbital momentum by a tiny amount. If the spacecraft approaches Earth in the direction of its motion around the sun, it is dragged along with Earth, and that's when there's an exchange of momentum. The Earth pulls the spacecraft along with it. In this momentum exchange, the spacecraft acquires momentum from Earth. That's a significant amount, as the spacecraft is very tiny compared to Earth that's enormously large. So as I told you, the spacecraft acquires its velocity from the exchange of angular momentum. So if we make similar zillion flybys of Earth, we will decrease its angular momentum so low that it will crash into the sun. If we repeat this process in opposite direction, that is, if the spacecraft goes in opposite direction to the Earth's revolution, then the momentum will be transferred in opposite direction. The spacecraft will give momentum to the planet itself. The angular momentum of the planet will increase by some amount that's insignificant, and the speed of the spacecraft will decrease. Even this technique is used to slow down spacecrafts in space. So we perfectly timed our flyby around Earth, and now we have acquired a large amount of angular momentum, that's the velocity to reach Jupiter. And our spacecraft will safely reach Jupiter. So the story that we made up is an actual story of the Juno mission, which will actually reach to Jupiter this year. So if you liked the video, please give it a thumbs up. Share the video with your friends. Subscribe to my channel for all the future videos. You can watch my previous videos by clicking here, or the eye that pops up over here if you are a mobile device. Thanks for watching, and as always, stay curious, stay awesome.